Hello everyone, I'm very happy to be here with you. My name is Marcelo Saraiva. I work with Automation Technology Management here at Klabin. I'm very happy to be able to talk to Professor Adriano Leal. He works in the Technology Research Institute. He sits as the technical manager in the Artificial Intelligence Analytics department in the company, and he performs roles and tasks that are related to this field. And he is also a professor and doctor in electric engineering focused on automation. He majored at the Polytechnician University in 2006. He also had a scholarship at FAPESP as a researcher. And he studies a lot about machine learning, Internet of Things, and things that are related to the Intelligence 4.0. So, yes. And now we are going to speak a little bit about machine learning. And as part of this topic, which is a very interesting topic, I would like to ask you, Professor, at the end of the day, what is the relationship between data science, artificial intelligence, and machine learning? Hello, thank you so much, Klabin, for the invitation. Thanks for the invite. And I would like to answer this question by saying that data science is the major knowledge that deals with processes, concepts, and tools and technologies that enable the analysis and extraction of knowledge based on rough data. In other words, data analysis is a process, and this process is about examining data to draw conclusions. That is, to draw conclusions about the information contained in this data. And for that much, we use tools and analysis systems. One very important aspect about it is data curatorship. We have to curate the data that are collected by those sensors and systems. So the work of a data scientist really starts when this data gets to a data repository. And so you have this major field, which is data science, and behind data science, you have artificial intelligence. Artificial intelligence is about how to allow those computing systems to simulate an intelligence that is similar to human intelligence, and that goes way beyond programming specific orders. The idea here is for those systems and machines to make decisions in an autonomous way, which is based in patterns. The artificial intelligence field is a very comprehensive one. There are many subfields of study here. One of them is machine learning. So this is a subfield of artificial intelligence, which is the study of how to make our computers learn without being explicitly programmed to do so. Folks that are a little older, they remember how we used to do procedural programming. So if the temperature is above this threshold, the machine should do this. But no, the idea is to extract additional knowledge from the machines to be able to make decisions without them necessarily being programmed. For that much, we have three types of learning. We have supervised learning. Supervised or overseen learning has to do with the data scientist, the person in charge. He selects entries and outputs, and then the algorithm, what it does is it maps those inputs and outputs and extrapolates knowledge. So with that, you have a very intensive effort that data scientists have to undertake to teach the machine to do that. And you have the non-supervised learning. Initially, you don't teach the machine based on previously programmed inputs and outputs. but the algorithm identifies the pattern, and with its cost function, it tries to minimize the cost. And by doing that, the algorithm learns in the proper way. And there is a third one, which is reinforced learning, which is a little more complex, but it's along the same lines. You know, the objective is to not not necessarily not have the data scientists tell what is the better option. So in a nutshell, that's what it is. Very interesting stuff. Now, to your comment, Professor. Of course, we understand that this tool is being broadly applied in equipment and in machines, but what is your opinion in terms of what types of equipment, what types of systems, or what types of components that are going to have, you know, most of this application in the next few years? Well, in the next few years, what we are observing is that there is a migration from the intelligence that at this precise moment it's actually post-processing. So in other words, you do a batch processing and you get a well-programmed network. Now the idea is to do online learning. That is to say that the data is coming in and the machines are learning with this data. And there is a migration from the cloud systems to the equipment and also the components of those equipment. For example, one aspect that is related to that is that recently Army, which is a manufacturer of CPUs and equipment, it was bought by NVIDIA. So there will be a merger that is going to happen in the next few years between artificial intelligence, 5G, and OT. I mean IoT. And those aspects combined, sometimes they give rise to components like a valve with enough intelligence to say that, look, I've opened as a valve many times and you have to replace me real soon. Or you're going to have to optimize your operation to make sure that I can last to the end of the month, which is when you are going to do a maintenance with me. So that's what it is. In summary, the intelligence is going to migrate from major systems into devices and machine components. Understood? That is basically what happens. That's what's coming. Understood. So really the sky is the limit in terms of that topic, right? There's a lot going on in the field. And based on that, I mean, we understand what is data science a little more. We understand what are the pieces of equipment involved. And by the way, at Klabin, we already have a pilot that is underway. We are already working with it. There is a group of people in one of our units that is developing this pilot with excellent results. And in any case, this is a very promising field. But Professor, based on everything that you have mentioned here, and based on the context that involves all of these projects, what are some of the measures we have to take to make sure that the future projects that involve this application, this machine learning application, what do project managers have to be careful before they hire the service? Well, the essential thing is to have a very clear picture of where you want to arrive. But this is already traditional for all the projects. What differentiates the projects that are working with machine learning and artificial intelligence is that you have to do a preliminary study of the phenomenon that you are analyzing. You have to know if what you are trying to train your artificial intelligence to do is coherent. You have to know if that amount of data is enough to be able to infer a phenomenon that you are trying to analyze. So I think that the major tip is this. in the first month or in the first couple of months, you have to analyze the phenomenon in a very, very careful way. You have to assess what kind of data you have. You have to see if this data is enough to predict this phenomenon or not. But in addition to that, you need to do a follow-up. So there has to be some data scientist that is tasked with paying attention to the adherence for the entire period. I'm talking about the adherence to the phenomenon that you are analyzing. So the main difference is this. Don't look at it don't look at data blindly. You always have to verify if this data is in line with the reality. You always have to analyze the phenomenon in a way that is calm, so to speak. So we can understand that it's really important to have people that are knowledgeable about the process, to have people that understand the phenomena that may happen in terms of that analysis, right? And you also need data scientists to interpret those information. That's right. What it is a partnership. I would say it's a partnership between three areas. The business area, which is going to lay out the objectives, like reducing cost, or the objective might not be cutting costs, but reducing the time of the process. So you need someone to step in and say, look, here's the objective. We have to reduce time, we have to shorten our deadlines, or we have to reduce cost. And you need someone that is knowledgeable about the process. Here's how the process works. We can optimize this, this, and that. And you need the data scientist that is going to be an intermediary between both parties. That person is going to decide how to optimize and meet both sets of needs, and at the same time, all the while, maintaining the safety level of the plant. That's what is essential. Besides catering to both parties, you need to maintain a safe plant. Understood? Yes, this is really a fantastic field to be explored. Very interesting stuff. I mean, there is a whole lot of things for us to learn when it comes to that, and there is a lot of value for us to extract as well. We realize that this tool can add a lot of value. Great to know, Professor. So, once again, on behalf of Klabin, I would like to say thank you. Thanks to everyone who participated, and I'll hand it over to Professor Adriano for his final remarks. Well, thank you so much for the opportunity as well. It's great to be able to convey a little bit of our experience and give some tips. A good tip is, again, to study the phenomenon. I think that's the differential. That's what stands out about the new projects we're seeing. And in conclusion, yeah, again, I just want to say thanks to Klabin. Thank you so much for the opportunity of addressing an audience which is very large, as we are seeing at the Inova Klabin Festival. Thank you so much. Once again, thank you on behalf of Klabin, Professor.